All right, kids, we have some more parallelogram stuff today. Kids, what do you remember about opposite sides of parallelograms from the previous section? They're the same length, right? And what's true about opposite angles? They're the same, okay? If you had consecutive angles, they'd add up to 180 in there. But kids, here's the deal. If you have a parallelogram, you tell me the sides are parallel and the sides, or I'm sorry, opposite sides are parallel and opposite sides are the same length. And we're going to start looking at some converses of some of that stuff, which means kind of working backwards, and we'll see what that looks like in some of these core concept theorems down here. But guys, in 7.3, proving that a quadrilateral is a parallelogram is what our title is. The central question is, how can you prove that a quadrilateral, a four-sided figure, is a parallelogram? Okay, now you already know some properties about parallelograms from the prior section. Goals for today. All right, these will be our targets for the day. Identify and verify what, kids? Parallelograms, and then show that a quadrilateral is a parallelogram in the corner plane. We're going to have to recall a couple of formulas for that, distance formula and then some slope formula stuff, but I think I can help you with that today. Okay, so guys, just some quick vocabulary. I don't even have any words in there because we've talked about them so many times. Okay, I think you know what a diagonal is in a diagonal is in a polygon, right? Okay, so that's from one vertex to another one. All right, and then a parallelogram. Do I need to go over these two with you at all again, or are you pretty okay with those right now? I would hope so. So some background knowledge in terms of what we're doing. Kids, I'm right here where the core concept is in terms of core concept theorems. A couple things we're going to need to know here. Okay, what's the first one say right here, kids? Okay, it says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, notice how A and B is equal to what distance here, kids? C to D, right? Okay, so that's one pair that's congruent. And then how about BC to AD? What's true about those distances, given those tick marks up there? They're the same. Are opposite sides equal to each other? The left and the right are equal to each other. The top and the bottom are equal to each other. If you have that situation, then that has to be what kind of a shape here, kids? Has to be what? Parallelogram, okay? So that's going to be the parallelogram opposite sides converse. If you have a pair of opposite sides that are equal, it's a parallelogram, okay? The other one is this. If you have a pair of not opposite sides, but opposite what? Angles. It says if both pairs of opposite angles in a quadrilateral are congruent, then the quadrilateral is what? Isn't B opposite of D right here, kids? And that one arc mark says they're equal. Isn't A opposite of C? Those two arc marks are equal. So if you have opposite angles equal to each other, then what kind of a shape do you have again? You have a parallelogram. Absolutely. Okay. All right. So let's talk right here, kids. All right. Kids, it says in quadrilateral ABCD, AB is equal to what? And CD is equal to what? Is ABCD a parallelogram? Explain the reason. Well, we better draw something, don't you think? Let's just draw something that looks like this. Now, does this look like a parallelogram here? Maybe. Boy, that's a bad drawing. Okay. I'll do the best I can to try and sketch a parallelogram. Kind of looks like a parallelogram, does it? Do we know for sure it's a parallelogram? I'm going to call this A. I'm going to call this B. I'm going to call this C, and I'm going to call this D right here, the way I've got it drawn. Okay, that's the order that they listed this, isn't it? A, B, C, D. Okay. What two sides did they say were equal first? So AB is equal to BC. So I'll put one tick mark through those. What other sides did they say were equal? CD is equal to 80. My friends, this is talking about sides. Are opposite sides equal in length? Is AB equal to DC the way we've labeled these tick marks? Is the left side equal to the right side? Can we say that this is a parallelogram? No, because could I say opposite sides are not equal length? Oops. No, because opposite sides are not equal in what? Okay, how you feel about that example one, kids? Okay, again, if it's a parallelogram, opposite sides, opposite angles are equal. Okay, finding side lengths of a parallelogram, my friends. It says, for what values of x and y is a quadrilateral STU be a parallelogram? Now, in order for this to be a parallelogram, wouldn't this side ST have to equal what? We would have to say 24 minus x equals what, kids? And I'm going to put a little line kind of right here. What other equation could I write here in terms of equal sides if that indeed is going to be a parallelogram? Okay, are you with me on that? Okay. Guys, help me solve that top equation up there. What might be a first step? Okay, add x to both sides, you're saying, Reese? And there's lots of different ways you can start this. So if you're going to add x to both sides, what do you get on the left side then if we add x to both sides, Reese? Good, 24. What are you going to have on the right side, my friends? Okay, all agree here, friends? Okay, next step. Okay, so this will be 18 equals 2x. So what's that make your x value equal to, kids? So your x value would have to equal 9. Okay, now, once I know x is equal to 9, couldn't I take that and plug this in right down here? Say, well, 2 times x, which we know to be what value, kids? 9. Wouldn't y have to equal 2 times 9 plus 3 here, kids? So I'm going to say 2 times 9 plus 3 would have to equal y now. Okay, help me with the math on that. What's 2 times 9? And 3 more? Absolutely. Y would have to be what? Is that in my imagination, or was Alexa talking back there? What'd she say?
I don't know.
Alexa, what did you say? Okay. Well, then keep quiet if there's nothing to repeat. She gets a little ornery sometimes. I don't pay attention to her, she gets jealous. Did you know that? Okay. You guys feel good about those so far? Pretty simple, isn't it? Okay. All right. A couple more theorems right here. One is called the opposite sides parallel and congruent theorem. Okay. I'm going to read this. It says if one pair of opposite sides of a quadrilateral are congruent, and what else? They're saying BC and AD are equal in length, and they are also, what do these triangles tell us, kids? Parallel. If you have a pair of sides that are parallel and equal, then the four-sided figure has to be a what? Parallelogram. Okay. There's also a parallelogram's diagonals converse. It says if the diagonals of a quadrilateral bisect each other, in other words, BD cuts AC in half, or vice versa, AC cuts BD in half, then the quadrilateral that formed is a what? So if these are equal bisections of each other, then a parallelogram. Okay. So guys, in example 3 right here, it says there's a doorway shown. It's part of a building in England. And it says over time the building has leaned sideways. All right. Quick question. How do you know S is congruent to angle U? Okay, they are opposite. Well, first of all, do we know it's a parallelogram first? What's true about ST and VU? They're They're the same distance, and they're also what? So I'm going to say this. Since the side ST is congruent to the side, is it okay to say UV or VU? And they're also congruent, but they're also what, kids? And that's how you write parallel right there. And ST is also parallel to VU. Wouldn't ST UV have to be what kind of shape? And in a parallelogram, what's true about opposite angles? So I'm going to say angle S must be congruent to angle U because they are what? Is it okay to say they're opposite angles in a parallelogram then? They're going to be opposite angles in a parallelogram. So again, we know it's a parallelogram because ST and UV are parallel and congruent. So that makes it a parallelogram. And that would be the opposite sides, parallel and congruent, converse. And then once you know you have a parallelogram, what's true about opposite angles again, kids? They have to be the what? Have to be the same. How you feeling, kiddos? Yeah, thumbs up if you're good so far. Anybody need more time in this page right now? Let's roll to page 3. See what I can find here. Oh my gosh. Number 4. What's true about the diagonals here again, kids? Diagonals cut each other in what? Half. It says for what value of x is quadrilateral CDEF a parallelogram? Well, kids, this distance F to N has to be the same as the distance from what to what? N to D. So what must be true about C to N and N to E? They have to be the same. So what's the equation I'm going to write in here to try and make this a parallelogram, kids? (4x minus 11). You got it. I can't make this any easier, can I? What's our first step? I might suggest subtracting 2x from both sides. Is that okay? So I'm going to minus a 2x here on the right, minus a 2x on the left. Talk to me, peeps. What do you get on the left side? Well, let's go minus 11 first is equal to what? And then 2x would equal what now by adding 11 to both sides? 28. What's that make our x value here, kids? 14. Okay. Guys, I know I'm going quickly. Are you on board with me right now? Okay, pretty straightforward stuff. I think we know a lot of this already. Okay, just kind of working in a backwards order to say this is what you have. What's it have to be to make it a parallelogram? That's kind of where we're at with stuff. Okay. All right, so in order to be successful with this next one, it's going to say recall some slope and distance formula. Let's write our slope formula right down here again, kids. Okay. Kids, slope, this is a tricky one. Anybody recall the formula for slope? Okay, if you don't, I'll write it down. Oops, I messed that up. Should be x2 down there minus x1. Okay. Slope is going to be y2 minus y1 over x2 minus x1 here, kids. Okay, we'll look at that here in a second, but it's basically 2 points Plug in your second y value minus your first y value over the second x value minus the first x value. We need to recall that. Okay. And then kids, the distance formula. I don't know if I want to give you the distance formula. I think I'm just going to give you a glorified version of the... You guys remember this formula right here? I think I'm going to do it this way. Remember this right here? It's actually the Pythagorean theorem. You remember that? In a right triangle, the sum of the squares of the legs of a right triangle is equal to the length of the hypotenuse squared. Kids, let's talk down here. In a parallelogram, slopes must be of opposite sides. I'm going to write it this way. Slopes of opposite sides have to be the same. Okay? Slopes of opposite sides have to be the same. Do you also know slope as rise over run like this, kids? Have you heard of slope as rise over run before? Okay, I'm going to jot that down. Okay. And then the distance formula, I think I'm going to just kind of go Pythagorean with you because I think it's easy to see when we plot this here. So let's just talk on this real quickly, kids. First of all, in example number 5 there, it says identifying a parallelogram in the coordinate plane. The directions say show that quadrilateral ABCD is a parallelogram. Okay. Well, let me ask you this first question. Does it even look like a parallelogram? Does it look like a parallelogram? I'd probably say what? Yeah. I think it looks like a parallelogram, don't you? Okay. Guys, what's true about opposite sides? They have to be the same. I'm going to pick on a couple sides. I'm going to pick on this side here, the left side and the right side. Here's the deal. If I could show that they have the same slope, that would make them parallel, wouldn't it? And if I could show that they're the same distance, wouldn't that make them the same distance and parallel? And if I have one pair of sides that's parallel and the same distance, what kind of shape does this become automatically? A parallelogram, okay? I'm going to pick on two sides. I'm going to pick on the side AB up here. What side is opposite of AB, kids? CD, isn't it? Okay, let's do the slope of AB. All right, you ready for this? For the slope from A to B, or B to A, doesn't make any difference. What's the rise distance? How far do I rise from B to get to A? 2. What's the run? So the slope would be 2 over 2, right? Which is equal to what value? 1. Okay, let's do CD. Kids, from C to D, what's the rise? What's the run? 2 over 2 again, right? First question. Slope's the same? Means those two sides are parallel. Since I'm going to write right down here, okay? I'm going to write it right down here. Since the slope's equal, since the slopes are equal, the side AB must be what? Not necessarily the same, but parallel to what side? Okay, we agree with that? All right, so what I'm going to do here, guys, is this then, right? I'm going to put a C value here and a C value here, okay? Let me ask you a question. What's true about this right triangle, A squared plus B squared? Wouldn't that be 2 squared plus 2 squared to find this distance C? Okay, so I'm going to go ahead and say the C value here, okay? Couldn't I now go for distance for A to B? Couldn't I say 2 squared plus 2 squared has to equal what, kids? Couldn't I say it equals that distance C squared there? Would you agree with that? Okay, what is 2 squared? Plus another 2 squared. It's like 4 and 4, isn't it? Wouldn't this be 8 is equal to C squared right here, kids? Guys, what's that make your C value here then? What do I have to do to both sides to get C alone? Square root of what? C is a square root of 8, okay? Well, guys, for CD, isn't that the same thing? Don't I have a right triangle here and here to find this distance C right there? So wouldn't I do the same thing again there? 2 squared plus 2 squared equals C squared for my distance on CD. This will be 8 again is equal to c squared. Kids, what's c on that side CD, or what's the length of CD? What's true about those distances then? They're both the square root of what? So I'm going to say the distance from A to B is congruent to the distance from what to what? Which means these sides are equal, and they are also what? They're also parallel. They're equal and they are parallel here. If they're equal and they're parallel, then what kind of shape does this have to be? Okay, so I'm going to say, since you have these two conditions, then ABCD must be a what? Say it loud. Must be a parallelogram. Okay, ABCD must be a parallelogram. All right? Is there anything on that fourth page, Reese? Blank. Guys, tell me how you feel about this today. Pretty good? Okay. I'm going to go ahead and stop our recording.